Hi guys, today is Math 8 Day 27. We just have one lesson we're going to look at, and that's going to be lesson 74. It's going to get turned over there. So in this one, we're looking at simplifying square roots. So again, if we square something and we take the square root of it, we can work back and forth between those. Just like addition and subtraction or inverse operations, we can use that to simplify equations. Multiplication and division, our inverse operations, so we can use those to simplify equations. We will also have some equations where we have some squares and square roots that we need to use in order to simplify equations. So when we're simplifying them, again, the Pythagorean theorem is an example of when we need to simplify. If we have a triangle with side 3 and 4, we do 3 squared plus 4 squared, and that equals 3 squared is 9 plus 4 squared is 16, that equals 25, and then we take the square root to tell us what our hypotenuse is. All this is showing is that, and you may see, actually I'm pretty sure we have a few test questions that are multiple choice, and we'll show you this kind of image and ask you, what is this representing? This is the Pythagorean theorem. So if I have A, B, and C, and then I square that, again, this is where the Pythagorean theorem comes from. Well, if I take this distance and make it a square, take this distance and make it a square, those two squares are going to be equal to this distance now made into a square. So that's how, way back when, I guess when they were looking at this and trying to find the relationship between the two legs and the hypotenuse, this is what they used to come up with the a squared plus b squared equals c squared. It's not always going to work out to be like 3, 4, 5. Sometimes we're going to have a hypotenuse that we're taking the square root of a non-perfect square, which is actually an irrational number. So square root of 2, square root of 3, square root of 5. Those are all irrational numbers, decimals that continue on forever, just like pi, and they never terminate or repeat. So we will write those just as root 2 or root 3 or whatever it is. If it is a perfect square like the square root of 4, well, that's 2, so we'll write that as 2. But sometimes we won't be able to simplify. Okay, and these rules are on your reference sheet. I can show you when we get to class. It's in that algebraic side where it's talking about properties. I think they use A and B. So if we're doing square root of A times B, this is all under the square root symbol. We can break this apart, and this is going to be the same as the square root of A times the square root of B. So when we can use this is when we have a factor that is a perfect square, we can factor that out in order to simplify it. Or if we have something like this and we need to work to get them under, for example, the same one, if we had, let's say we had the square root of 2 times the square root of 50, well, this is irrational and so is this, but if we multiply them together, we get, working backwards from this property, if we can break apart A to B, that means we can combine them under the same square root symbol. So this is going to give me the square root of 2 times 50, which is 100. The square root of 100, I know, is 10. So this is where understanding these properties and how you can work back and forth can help us to simplify some of these numbers. And we will see quite a few test questions with that. So again, that's how they should have it shown. I think it's A and B, maybe it's M and N or something like that on your reference sheet, but it's the same property. So remembering this and having it written down is going to be very beneficial. So if we have, to simplify these, again, the square root of 216 and the square root of 210 are not perfect squares. So we go to our calculator. Let me try to go to a calculator. All right, well, we know if we do the square root of 216, that gives us 14.6969384, and it's going to continue on forever. So we don't want that. We don't need it in decimal form. I'd rather keep it like this, but we can go in and say, okay, is there any perfect squares that go into this? Okay, and we have 216 is actually 6 to the power of 3. 6 times 6 times 6. Okay, so we can think about, oh, well, 36 times 6. 36 is a perfect square. So let's factor that out. Okay, well, 36 times 6 is 216. So let's use that property we just talked about to break it apart. Now I can do the square root of 36, which is 6. Okay. And then there's no perfect squares that go into 6, no factors that go into it that would allow me to simplify this down at all. So I can just leave it as 6 root 6. 6 times the square root of 6. And then one thing you can always do to check your work, I don't have the overhead to show you how to do this in your calculator, but just go in and do the square root of 216, hit enter, okay, and then do 6 square root of 6, hit enter, just like it shows right there, and then you're going to get decimal numbers, and they're going to be the exact same decimal numbers. So that's a way that I'll go through, and I'm like, did I do that right? If it's a big number that I'm not used to working with, did I do everything correctly? Well, you can just input both of those values and they should be the exact same. If they're not, you know you did something wrong. Okay, and again, we can do our prime factorization. I think it's easier if you can see, obviously, a perfect square that's a factor. If we do it this way and we do, well, 2 times 108, 2 times 54, 2 times 27, 3 times 9, 3 times 3. Okay, yeah, we can do it that way. I get 2 times 2 times 2 times 3 times 3 times 3. And then I can rearrange these. I'm going to multiply in any order. So this can become the square root of 2 times 2, which is 4. Square root of 4 is just 2. 3 squared, square root of 3 squared is just 3. That'll give me 9. Square root of 9 is 3. And then 2 times 3 is 6. So again, if you would prefer to do division by primes or prime factorization and then rewrite it this way, you can, and sometimes you may have to do that if you don't see the largest factor right away, but we're going to end up with the same answer. If we have 210 and we try and do that, well, 21 and 10, 3 and 7, 2 and 5, so there's not any perfect squares that go into it. We can write it as the square root of 3 times the square root of 7 times the square root of 2 times the square root of 5, but that's just multiplying 4 irrational numbers together. We might as well just keep it as the square root of 210. All right, and then looking at some of these approximate values, again, they're irrational, so they go on forever, but to give you an idea of where they were, if we were plotting them on a number line, square root of 2 is about 1.4. Square root of 3, 1.73. Square root of 5, 2.24. Square root of 10, 3.16. And then again, we can always, we've done this way back at the beginning of the year, but we can always figure out what numbers these are between. Well, I know the square root of 1 is 1. The square root of 4 is 2. So the square root of 2 and the square root of 3 have to be between 1 and 2. Okay, square root of 5, well, I know the square root of 4 is 2. The square root of 9 is 3. So the square root of 5 has got to be between 2 and 3. And it's a little closer to 2 than it is 3. It's closer to the square root of 4 than it is the square root of 9. That's another way you can kind of figure out. All right, that practice set, we will do that as a class. So have this video watch, and then we'll go over that in class together. All right, see you soon.